Today's lesson. Listening. Today's lesson is pretty much the nitty-gritty of Chapter 2, what you'll be assessed on. These are the two and only two dot points from your study design that you're required to understand to do the exams. Most of the questions on the exams are probably going to be... They're probably going to be a multiple choice question. So if you're having a look at your Chapter 2 review exam questions, you'll find that a lot of it is multiple choice, and which is fairly easy, good. That's, you know, calculator work right there. But if you look at previous years, and some of them are exam 1, you are required to know how to do it by hand. Now, it seems like in the design doesn't tell you that you need to know how to do it by hand, but just in case it does come up, and you can't blame me that I didn't teach you, I'm going to show you how to do it by hand and how to use the CAS calc and what it means. And so that was last session, try to get you to understand if the inverse exists, then what does that mean again? X exists. But if X exists, then what does that mean? There's a solution, because again, it's an intersection of two lines. Whereas, when will an inverse not exist? When the determinant is 0. And if the inverse doesn't exist, then what doesn't exist? X doesn't exist. But what does it mean when X doesn't exist? Good. You only have no solutions or infinite solutions. So what does that mean though when you say no solutions? When they're parallel. That's the only way you don't have any intersections, or they're exactly the same lines. That's why you have infinite solutions. Yeah? You're going to use that understanding to answer these questions here. I'm going to show you at the very end. Okay? And that's what this is trying to say. But if you understood what I was trying to say, that's it. You don't have to look at that box. It all makes sense. Okay? What I just covered with you is just a quick summary of what I was trying to talk about last session. How to multiply, add matrices, how to find the inverse. This is the formula for the inverse. So if you've forgotten, write that down. You make sure you remember that. This is your determinant. Determinant of A. Obviously, if it equals 0, inverse doesn't exist. Inverse not exist. Okay? So because of that, the whole idea is you're trying to solve for X, and if it does exist, then these two cancel out and you can find X. And that's why you know that there's a unique solution, because if you find X, it tells you the coordinates of an intersection. Okay? Now let's do an example. Exercise2F, and it leads on to 2G, and whether you have 3 parameters or, 3 equations or not. Okay? Let's have a look. This is your typical Year 9 mathematics. 2 linear equations. You either use elimination method or substitution method to solve, right? We can use matrices now as well. We can use our CAS calc. You're not going to get these kind of questions in the exam, but it's just question 1 of 2F. Tries to get you to understand what you're really doing. So let's have a look at, let's look at A. Okay, I'm going to rewrite this using matrices, because you know how to do it using elimination method. You know how to use it using substitution method. I'm trying to teach you how to do it by hand. Okay? So let's do something simple. If I were to rewrite this using a matrix, then what you can see is what I've done is, to get 3x plus 2y, I've used matrix multiplication. You see that's a 3, that's a 2. 3 times the x gives me 3x. Plus 2 times the y gives you 2y equals 6. Remember matrix multiplication? It's a 2 by 2. And this is a 2 by 1, the result should give you a 2 by 1, which I do have. Row 1, column 1 gives you the answer for row 1, column 1, which makes sense. That's what we're saying. It's 3 times x plus 2y has to equal to 6, which is what I'm modeling up here. Same thing if you want to get that second line, to get 7, 7 will equal to 1 times x, so row 2, column 1, plus negative 1 times y, which is why I have that. So I've just modeled it using my matrices. And the nice thing about this is it's in the form of A, matrix A times matrix X equals matrix B. See, this is the whole point. This is what we've been doing. This is what I've been saying. that if you want to solve for x, which is the coordinates of intersection, you need to remove a. But remember, matrices doesn't have divide. It has no division. So the only way to get rid of it is if you find the inverse, so that when you multiply the inverse on both sides, this becomes identity matrix, those two cancel out, and you find out x. But you need inverse to exist first. So that's the first thing you're going to do. You're going to like, all right, well, in order to find out the coordinates, you need the inverse to exist. So let's check. This is my inverse formula. Really, we know the inverse exists as long as AD minus BC works. But if I were to do it, here we go. How did I get -5 on the bottom? Simply AD, which is 3 times -1, which is -3, minus B times C, which is 2 times 1, it's 2, so -3 minus 2, I get -5. I've rearranged it, so DNA I've swapped, so it becomes -1 and 3, I've swapped it, -1 and 3. And BC, it's -2 and -1. Yeah, -B, -C. So there's my inverse. So apparently it does exist. So if this exists, it means there must be a coordinate of intersection between these two lines. There's a unique solution. Okay, so they're not parallel and they're not the same lines. And you can tell just by looking at it. One has a gradient of -3, one has a gradient of -1. They're obviously going to intersect at some point. Okay, so it doesn't take a genius to look at that and say, oh yeah, definitely not parallel, and neither are they the same lines. So most likely it's unique. So if you do that, we're like, okay, so the coordinates x, y has to be A inverse multiplied to 6, 7. That's what I'm doing here. A inverse B. I found A inverse, I'm going to substitute it in. Do your matrix multiplication. Row 1 times column 1. So 1 times 6 plus 2 times 7, which gives you 20. And then 1 times 6 plus -3 times 7. So that will become 6 minus 21. Yeah? So what I get is 20 and -15. But don't forget, you had the -1/5 on the outside. You can times them both in. So what's -1/5 of 20? -4. And then -1/5 of 15. -3. So what does that tell me? That just tells me there is a unique solution, meaning there is an intersection at a coordinate, where? 483. Now you can do that on a calculator, or you can do that using your simultaneous methods, year 9 methods, doesn't matter. Right now I'm teaching you the matrix method, so that you can find out the coordinates of intersection. Now, like I said, you're not going to get these kind of questions in the exam, because that's year 9 maths. They can't force you to use matrices. So why am I showing you this? Is because the questions you're going to get in the exams is when they don't give you the values. So they might say, I don't know, kx plus k plus 1y equals to 6. Then they might have x minus ky equals to 8. Your job is to find out what k values are, so that you get a unique solution, no solution, or infinite solution. See, that's why I'm trying to push you to understand this concept, so that when they do ask you those questions, and it's in your sheet, the last 2 questions, 2G for the exam revision, you'll see what I mean. And we're going to do the first one, I'm going to leave the last one for you to do. Okay? Any questions? Yes, Stephen?
Is that inverse wrong?
Ah, you're right too.
And then
Yeah, you're right. There we go. I did it beforehand, so it should be right. Let me just check it again. -6 minus 14. Oh, that becomes minus 20. And then this is -6. Is that a plus 21? -6 plus 21 is positive 15, so it's swapped around. Sorry, thank you. It's positive. Oh, but I got the right answer. Ah, how about that? I'm just a magical teacher, you see that? You know? Even when I want to get it wrong, I just get it right. That's how I aced my year 12 exam. All right, so let's move on to now this question, and I'm going to do, oh, that was just using CASCalc. So how do you use a CASCalc? Solve. Simple, 4, -3, done. Okay? Now, this question, I'm going to have the same go. I want you to rewrite C. Let's have a look at C. We want to know if it has no solution, one solution, or infinite solutions. And I know you can look at it and tell me what the answer is, but I want you to do matrix method. So write this, rewrite it using matrices. Then follow the steps I just showed you. Find if the inverse exists. If it doesn't exist, how do you know if it is no solution or infinite solution? Okay? So we go, rewrite this as a matrix. I'm going to start off by doing that. And it might be helpful this weekend to read ahead for chapter 3, because next week I might smash it all within 3 sessions. Yeah. Yeah, we're losing too many sessions. Smash it all.
We get late start.
Yeah, I know, that's a problem. So on the very last week, week 9, you get parent teachers on a Tuesday, so you don't have me. That's 2 sessions off, a double session. And then you come on a Wednesday, it's a late start, so you lose a Wednesday session. So you only get a Monday, Thursday with me. Last week.
We only got Tuesday.
So I'm going to cram it in. I'm going to overload you with stress.
Pretty much my life right now.
Good. Excellent. So we'll test after test. All right. Have a look. Did you write your matrices as the following? Unless I copied it wrong. Did I? No. That's all right. It's cool. Hands up if you got that correct, the matrix form. Fantastic. Okay. So now we rewrote it. We want to find xy. We want to find matrix X. Remember, this is matrix X, matrix A, B. If A inverse exists, then I can cancel these 2 out. If it doesn't, I can't. Therefore, I can't find X. So my first goal is there an inverse or not? So that's my first step. Let's work out an inverse. It depends on the determinant. So the determinant is AD minus BC, so 1 times -4, which is -4, minus -2 times 2, which is -4 again, and that gives you -4 plus 4, which is 0. And we know when the determinant is equal to 0, what does that mean? Inverse doesn't exist. If inverse doesn't exist, what does that mean? X doesn't exist. Now, if X doesn't exist, there's only 2 possible ways. If X doesn't exist, then there's only 2 reasons. You either have no solutions because it's parallel, or it's infinite solutions, so it's the same line. Those are the only 2 times or 2 reasons why you can't solve it. So, the question is, are these 2 lines linear, as in like parallel, or are they the same line? So the only way to do it is by rewriting both. So I rewrote the first line in terms of y, and we can see that gives you y equals x on 2 minus 3 on 2. And I rearranged both sides, and we've got x on 2 minus 3. Now what we can see, same gradient, different y-intercept. That has to be parallel lines, no solution. They have the same gradient, different y-intercept. So therefore they have to be parallel, they're not the same lines. So therefore, this question C, the question is, which one is it? It's no solutions, based on that concept. Okay, now what I've done with numbers is exactly what you're going to do in the exam, just with letters. So everything that you've been doing so far is just going to be with letters. Same concept, same process. Okay, because that's what they're going to ask you. They're going to ask you, when is it going to be no solution? When is it going to be infinite? And when's it going to be unique? Simple as that. And all you have to understand is whether inverse exists or it doesn't. If it does, and what it means. That's all you have to understand. Okay? All right. Let's move on to a problem so that you can practice. Oh, what is this? Oh, this is a calculator. Oh, another thing I noticed with the calculator as well. If you type it in the exam, if it's a multiple choice question, you solve it and it comes out false, it's going to be no solutions. Okay? Whereas if it's infinite solutions, for example, this one, this is an example from your textbook. If you actually do the solve, this comes up. Now what you notice is it's not an answer. It has C1, we call this a parameter. Anyone know what a parameter means? What's a parameter? You're dealing with it your whole life when it comes to maths. What is a parameter? No? A parameter, you know when you have y equals ax squared plus bx plus c? A, b, c are your parameters. When you learnt y equals mx plus c, m and c are your parameters. Variables are different. Variables is in an equation x and y, whenever you change x, it will change y. But m and c stays the same. So for example, y equals 3x plus 2. 3 and 2 stays, but x and y will change. So these vary. That's why they're called variables. So when x is 1, you get y is 5. But 3 and 2 stays the same. So parameters, yes, they can be different, but the parameters are constant for that particular equation. Okay? So what are we saying here is C1, the calculator calls it a parameter. So depending on what C is, you will have a different value for x and y, because x and y are your variables. So in your textbook, we usually use the parameter, and when you're in the exam, they might probably prefer you to use this symbol. That's called lambda. Okay, if you want to spell it, it's like da. Okay? Instead of using C1, what they want you to use is lambda. Okay? Now, lambda is no different. Lambda is no different from A, B, C, M, or C. Okay? It's the same thing. It's just a number. We just like to use lambda. And traditionally, conventionally, we know that that means a parameter. Okay? So when you write your answers in the exam, you'd say y equals to, in our case it says y equals to lambda. Therefore, x equals to -3 times lambda minus 2 and 2. What does that mean? All it means is that all the points of intersection, remember this is an infinitely many solutions, so all the points will lie on, and because it's not unique, you can have these coordinates. You can have when y is lambda, then x is this. And that's how you write your coordinates. And what does it mean? It just means like if, for example, if lambda was 2, then you would have 2 minus 2, which is 0. 0 divided by 2 is 0. And lambda is 2. So that's one point of coordinates. But then if lambda was 3, then you do the same thing. You say 3. 3 minus 2 is 1, so you get -3 on 2, 3. And that's why there are infinitely many solutions. And it goes on. And it follows this rule. And that's what you're going to write in the exam. When they ask you to write it as a parameter, that's what they're asking. Because every year some students will ask me, and I'm like, what is a parameter? I never learned it before. And I'm like, yes, I have taught you, lambda. And they're like, lambda? What is lambda? I'm like, don't worry, just keep calm and move on, you know? So it's exactly the same thing as you've been doing. There's infinite solutions because they're infinite coordinates. That's how you write it. Okay? So just keep that in mind, parameter, lambda. All right, are we ready? Because next slide, I'm going to give you an exam question. I'm going to get you to think about it. I'm going to guide you after, give you like 5 to 6 minutes. It's a 4-mark question, so it should be 6 minutes maximum. Shouldn't even take that long. I give it about 2.5 minutes to do, and hopefully you now have an idea what you need to do. Okay? So read the question first, and I'll tell you to start. All right? This is in your sheet that you got for the revision. So this is probably an exam one of the previous years before the course change. And so I don't know if it's going to come up this year, but if it does, at least you know how to do it. So the question says, consider simultaneous linear equations. So you've got two straight lines. You've got an x, you've got a y, you've got an x, you've got a y. What's the difference between the ones I've just shown you before? These don't have numbers, these have letters. That's the only difference. So it's kx minus 3y equals k plus 3. You're like, oh my god, too high. No, the same thing. Same drill. Where k is a number, real constant means a number. Find the value of k for which there are infinitely many solutions. Now that you understand, infinitely many solutions only occur when? The inverse? Yeah, what about the inverse? When it doesn't exist. But when won't the inverse exist? Yeah, when the determinant AD minus BC equals 0. So that's your first step. That's what you should be doing. Or you can follow the steps I just showed you, rewrite it as a matrix, see if the inverse exists, and you know that inverse will not exist for these solutions. Have a go. Just have a go. So I just gave you a guideline. Once you can answer A, which is 3 marks, you can then easily answer B, which is what is it unique? See, that's all they're asking. When is it unique? When is it infinite? Sometimes they change it and they say, when is it no solutions? When is it unique? Same drill. Same drill all the time. Okay, so have a go. I'm going to give you 6 minutes. And I'll show you the answers. I want you to have a go. Have a think. It's not hard. It's not a hard question. This chapter's straightforward. One concept. Plus. They never write the divide symbol, they always do the fraction. So, yeah. Got about 3 minutes left. All right, let's go through the answers. Now, hands up if you at least got up to this step. You found the determinant is k squared plus 7k plus 12. Hands up. Okay, good. Okay, so we wanted to find the determinant. Now remember, we said we want infinitely many solutions. That only occurs if the determinant is 0. Because if it's 0, there's no inverse. If there's no inverse, x doesn't exist. That's what we want. Okay, in our case, that's what we want. So we want it to equal to 0. So because we want it to equal 0, the next step should be, well, if it equals to 0, what k values, and this is quadratic, what should k be to make that 0? That's where you can factorize. Hands up if you factorize the next step. Okay, good. Hands up if you factorized it correctly. Good. So therefore, what you would have found out is that the inverse will not exist if k is negative 3 or k is negative 4. Hands up if you got up to that at least. Okay, excellent. Because that is your 2, it's 1 or 2. I think it might be a 1 in this case because you've got to prove 2 of them. There's 2 things you've got to prove. Otherwise, if they're generous in that year, they'll make it 2 marks up to this step. 2 marks for getting k negative 3, k negative 4. So see the way I'm laying it out? Determinant will not exist. Inverse will not exist when determinant equals 0. So, now the problem is, when it doesn't exist, when the inverse doesn't exist, you have 2 possible reasons. It's either it's parallel or it's infinite. So the only way to know is if you figure out back into the straight line again, you sub it all back in and you're like, is it the same line or is it a different line? That's what we did before. Yeah? So same thing here. I'm saying, all right, so which one will give me the infinite solutions? Let's try k equals negative 3. So if k equals negative 3, I'm going to sub negative 3 back into both equations, both of these linear equations here. So if k was negative 3 and this is negative 3, I'd get that. And then I sub same thing again, negative 3 in here, and I get this. So looking at those 2 equations there, I've got y equals negative x because I rearranged it, and I rearranged the second one. I've got y equals negative x plus 1/4. What does that tell me? When k equals negative 3, what situation do I have here? Yeah, they're parallel. But that's not what I'm looking for. They said infinitely many solutions. This is a no solutions problem. It's parallel. But you can't stop here and assume that k equals negative 4 is infinite. In the exam, you must prove it. You got to show it. You can't assume. Because it might be both parallel. You have no idea. Okay, so the next step, in order to get your last mark, which is your third mark, you got to try when k equals -4, and you have to do this. That's why in your sheet, it would have gave you a lot of lines, enough lines for you to do this. Okay, and that's why it's a 3-mark question. Anytime in the exam, 3 marks is not an easy mark. The third mark is always a justification mark. Whether it's chain rule, differentiation, every time you get a 3-mark question, there's a justification. You have to prove something that is not, something that's not possible. In that case, k can't be -3. So, if you do the same thing again, you sub it in, you'll realize by subbing -4 in, you'll get exactly the 2 same lines, and therefore, when k equals -4, it is the same line, therefore you have infinite solutions. That's your answer. So you have to have that. And see, that makes sense why it's a 3-mark question. Why it takes a lot to prove. Yeah? Now, like I said, once you know k equals -4 will give you infinite solutions, now answering that 1-mark question is really easy. It says, find the values of k for which there is a unique solution. So when will you have a unique solution? So when k is not parallel and when k is not infinite. And the only time that occurs is when k either equals -3 or k equals -4. We don't want that. So as long as k is anything except for -3, -4, you're good. If you wrote k can't equal -3 and k can't equal -4, not good enough. Because you just told me what it can't be. You didn't tell me what it is. The question says, find the values of k for which there is a unique solution. You just said k can't be -3 and k can't be -4. So what can it be? You haven't answered my question. Write it out using your notations. K is an element of real numbers except for -3, -4. That's what they want. Okay, so it's not good enough if you just write k isn't -3, k isn't -4. You haven't answered the question. Okay? The question didn't say, what can't k be? Because if that was a question, you answered it. But you got to answer the question, what can it be? How is that? Does that feel good? Yeah? Because in your sheets now, you can go through that now. Last question on that sheet, the exam revision, same thing, it's multiple choice. I want you to have a look at that sheet again because that's the only concept you need to learn from chapter 2. Remember I said study smart, don't study hard. That's all I'm asking you to do. 2F2G, just pick a couple of questions, get your head around that. All right, and over the weekend, read chapter 3 for me. Transformations, because I'm going to whip through quite a bit of it, so read ahead. Oh, I'll print you another one. Okay, just at lunch, just print you another one. You another one too?